Okay, so let's get started with the section 1.5 notes on polynomials. The objectives. So after this lesson, you should be able to recognize and define vocabulary of polynomial expressions. And also, you should be able to rewrite expressions in descending exponential order. Okay, so I started off the notes for you here. Okay, so again, anytime you want to pause the video to go ahead and give yourself time to copy stuff down, you can. So we'll start off with some vocabulary. The first one is called a term. So a term is a coefficient and or variables linked by multiplication. Okay, so that's a term. It's a coefficient and or variables linked by multiplication. And you see here some examples like 5x, which again we know is just 5 multiplied 2x, but together we just write 5x, or 2xy squared, or 4x squared y z cubed, right? Every one of those factors that make up the term are being multiplied to each other, making up just the one term. So each of these are considered a term. Next vocabulary word is polynomial. It's a collection of terms or parts linked by addition and subtraction. Okay, so it's the addition and subtraction symbols which, separate out the terms in what's called a polynomial. And there are some examples of polynomials. Some polynomials have 3 terms, like x squared plus 3x minus 7. Okay, so again, those are 3 terms separated by a plus sign and a minus sign. And we have 5x cubed minus 4, and that polynomial has 2 terms. And we'll get more into that as we go along with the notes. All right, next 3 vocabulary words are dealing with the number of terms in a polynomial. So the first one is monomial, which is a polynomial with only 1 term. And there's your examples. A binomial is a polynomial with 2 terms. And a trinomial is a polynomial with 3 terms. Okay, so again, reminding you that to count the number of terms in a polynomial, you just count what's in between the plus and the minus signs, right? All right, so I'll give you some time to see if you can find the answers for number 1, which says classify each polynomial by the number of terms. All right, so part A, can count in the number of terms. Again, we are keying on the plus signs that separated out the terms. So I have 1, 2, 3 terms, and because I have 3 terms, that's considered a trinomial. Okay, part B, again, looking at the plus and the minus signs that separate out the terms. So that means I have 1, 2, 3, 4 terms in this polynomial. Now, in the above vocabulary list, we did not have a specific word for a 4 polynomial expression or 4-term polynomial. So therefore, we're just going to call it polynomial. So anything that's above 3, so 4 and above, all right, we're going to classify that polynomial by the number of terms by simply just saying polynomial. Part C, I've got 1, 2 terms, right? Those 2 terms are separated by a plus sign, thus it's a binomial. Part D, we do not see any plus or minus signs. We just see the y cubed, so that's only 1 term, and that makes it a monomial. All right, moving on to the next page of notes. So we got the next vocabulary word is standard form. So when we talk about standard form, we're talking about a polynomial that is written in decreasing exponential order. meaning when you look at the exponents that are used to make up the terms, standard form means you're going from the biggest exponent down to the smallest exponent in terms of the terms. And we'll get some examples here in a minute. The degree of a polynomial is the largest exponent in the polynomial. The exponent in the first term when the polynomial is written in standard form. So again, you're going to see why it's important to make sure that before identifying the degree of the polynomial, it needs to be in standard form. Okay. And finally, the leading coefficient is the coefficient of the term with the highest degree when written in standard form. So again, you can see in those last two definitions why it's very important to make sure that we are working with a polynomial in standard form. Okay, so before we get into examples of these, a few more ways to classify polynomials, and this time we're going to classify it based off of the degree. So if it's degree 0, we're going to call it a constant. Degree 1, we're going to call that polynomial a linear. Degree 2 is a quadratic. Degree 3 is a cubic. And degree 4 is a quartic. Okay, sometimes students get degree 2 and degree 4 mixed up because they both kind of start off the same way. Okay, so make sure in your notes you got degree 2 is quadratic with a D, and degree 4 is quartic. Okay, so let's go through example 3 together. Here we're given a table that has two polynomials in it. It says write each expression in standard form and then classify the polynomial by the number of terms and degree. And then finally, state the leading coefficient. Okay, so let's take a look at example A. All right, so we first want to write this polynomial in standard form. You can recall standard form means we're going to take the terms and we're going to order it from biggest exponent to smallest exponent. Okay, so we see that this has three terms. Okay, we get the minus sign here, the plus sign here. All right, so we have three terms we are working with, and this one in the middle here has the biggest exponent. So that should be written first when we're going to rewrite it in standard form. Okay, so again, we're going to take this term. Now we got to make sure we take the sign along with that term, so that negative is in front of the 10. So when we move that term to the front, we got to make sure we take the sign along with it. So now we have negative 10x squared. We have these last two terms here. This one has an x to the first power, so that has an exponent of 1. Now this one doesn't have an exponent. I mean, it doesn't have a variable. All right, so since this doesn't have a variable, then we are assuming that the exponent to that is going to be 0. Therefore, we're going to go ahead and write this 12x next, and then this 4 would be last. Okay, so there is our polynomial in standard form. Let's go ahead and move down the table. The number of terms, again, we said there's 3. So we need to classify based off of the number of terms. Since there's 3 terms, it's considered a trinomial. Okay, again, we got to make sure that when we are classifying these polynomials, we want to know, hey, are we classifying by terms or are we classifying by degree? Next, we want to know the degree of this polynomial. Again, we're looking at the biggest exponent. So here the biggest exponent is 2. So it's a degree 2, meaning it is a quadratic. Oh, actually, that should be down here. It's a quadratic with degree 2. Leading coefficient, again, because we wrote this in standard form, the leading coefficient is always going to be the number that is in the lead term. So since this is in the leading coefficient would be negative 10. Okay, let's go ahead and do the next one together. Standard form. Again, we have 1, 2, 3, 4 terms in this polynomial. All right, so but this is the one that has the biggest degree, so we're going to write that first. Next with the x squared term, and the 7x, and then finally the constant term at the end. Again, because we have 4 terms, okay, so 4 terms, that's going to make it a polynomial. Degree, the biggest exponent here is 3, and because it's a 3, it's going to be a cubic. Again, classifying it by degree, because the degree is 3, it's cubic. Leading coefficient, again, because we put this all in standard form, leading coefficient should be easier to find and identify, always up front, is 8. All right, I'm going to give you some time here to work on these next 4 examples. Again, for each of them, you're writing the expression in standard form, classifying the polynomial by the number of terms and degree, and then state the leading coefficient. All right, so then when you're done, you can go ahead and continue on with the lesson video to check your answers. All right, let's go ahead and check your answers to part C and D. A few things I want to point out here with C being just a 6. Okay, so when it comes to the degree, okay, so again, if it's just a constant, the degree is always 0. Okay, again, when we talk about a constant, meaning again, there is no variable involved. All right, so parts E and F, okay, making sure, again, with like problems of E, you want to take all those terms and write it in standard form, making sure that it goes from the biggest exponent in the term to the smallest, in this case, a constant. Remember, when you're rearranging, make sure you take the signs along with the terms. Because this is a 4th degree polynomial for part E, remember that's quartic. And the leading coefficient is always the coefficient, is always a number in the lead term. All right, so let's finish it up here with answering this last question. What is the difference between classifying a polynomial by degree and by the number of terms? Well, when you're classifying by degree, you are using information from only one term of the entire polynomial. Again, that's usually the lead term. When you're classifying by the number of terms, you're going to be using the entire polynomial. Okay, that's the end of lesson 1.5. If you have any questions, make sure you ask. Go ahead and get started on the homework.